Hello everybody and welcome to the homework helper for section 3.4. Coming a little late today, but it'll be up soon enough. All right, let's go ahead and start with our first section, our ready section. It wants us to talk about the attributes of linear and exponential functions. And it wants us to compare and contrast linear and exponential functions and be sure to include as many characteristics of each function as possible and to be clear about the similarities and differences between these functions. So just as a reminder before you begin to answer this question, I'm going to talk a little bit about linear and exponential and give you some models to start with. I mean, our first model, of course, is visual, where we know that linears are going to behave like such, where we have a straight line, whereas our exponentials tend to behave like this. Okay, so we end up with these. There's growth happening for both, right? There's some sort of growth. It's called one thing for a linear, our growth is called a common difference, but for an exponential it's called a common ratio. We see that that's definitely a similarity, but it's also different because this increases so much more faster, right? A constant ratio is going to be a much more extreme or fast way of doing such, whereas our common difference is slow and steady. There's intercepts. Intercepts are going to be the same. Exponentials will have some sort of line that they can't touch called an asymptote, and such like that. We know our equations, right? Our equation for a linear is going to be some f of x equals our n sub 0 plus our common difference times x, which is the same as y equals mx plus b. But then for our exponential, our n sub 0 is being multiplied by the common ratio, and instead of timesing x, it's raised to the x power. So a little difference, but something to keep your mind on. So that's a starting point, and try to think about some of the other differences and similarities you may know. For the set part, it wants us to use each graph to identify the domain, the range, increasing or decreasing, and then it wants us to use interval notation when we talk about this. So for domain, we're always thinking about all possible x values. So this is our x-axis, and we see -5 is the start. There's nothing less than -5, and it continues on till about 2. So it goes, I know from -5 to 2. -5 is included, we know, because it's a solid mark. But here it's an open circle, so that means it's going to be a parentheses, because it doesn't exactly reach 2. So that'll be our domain. Our range is our y, so our lowest value is -6, and it goes all the way up to 5. -6 is the open circle, so it'll be a parentheses, and 5 is a solid circle, so we'll do it like that. And then whether it's increasing or decreasing, as we move left to right, we see that it goes down. If this were a Super Mario Brother character, we'd see he'd slide down, so we know that it's decreasing. Okay, so the same here, domain, range, increasing or decreasing. Domain is all possible x's. This arrowhead tells us it goes on forever, so this would be -infinity would be the smallest number, and then from -infinity it stops at 4, but it's an open circle, so it's a parentheses. Our range, our lowest number is -6, and then it rises all the way up to, well, it looks like it's an exponential, and exponentials have asymptotes. So because of that, we know that that's going to go up to -1, and that's going to be a parentheses for both. And again, as we read from left to right, we see that it's decreasing. Okay, let's do a couple more. Okay, domain, range, increasing or decreasing. All right, what are our possible x values? Well, this appears to be going on forever, so that would be -infinity. It goes on forever, that would be +infinity, parentheses for infinities. Range, well again, it's going down forever, so -infinity. And then it appears to hit an asymptote around 4, so we'll call that 4. Okay, and then as we go from left to right, it's definitely increasing. Okay. This was on the quiz, so I'll skip this one. But let's go to number 6. Okay, number 6 is a linear. So our domain, we know it would go on forever and ever, so -infinity to infinity. Our range, those arrowheads again tell us -infinity to infinity. And is it increasing? Yep, it certainly is. All right. Finally, let's go to the go section here. It wants us to find both the explicit and recursive equation. This should be a bit of review, but just as a reminder, for a arithmetic, or in this case linear, explicit would be f of x equals our n sub 0 plus our common difference times x. Recursive would be f of x equals f of x minus 1, and then plus our common difference. And then for an exponential, f of x equals our n sub 0 times our common ratio to the x power, or recursively, f of x equals our n sub 0, or I'm sorry, f of x minus 1 times our common ratio. Let's do it right instead of just writing the same thing over again. Okay, so first of all, we need to look. What is this? Is this linear or is it exponential? Well, I'm adding 2, I'm adding 2, I'm adding 2, so I know that it's linear, so I know I'm going to use these rules. My explicit form, well, I don't know my n sub 0, but I know my n sub 1. So I can either work backwards and see what it would have been. 0 would have been 1. So I can say 1 plus 2x. Or something else I could have done is, since this is my first term, I could, instead of putting my n sub 0, I could put that first term there. I could say f of x equals 3 plus 2, but since it was my first term, I have to say x minus 1. And then recursively, it's f of x equals f of x minus 1 plus our common difference, which we know is 2. All right, here, let's check it out. So here we see that we're, well, that's adding 4, but I see that's not going to be it. So I think it's exponential. Times 2, yep, it's exponential. Times 2. Explicit form, f of x equals, and then again, I don't have my n sub 0. I mean, I could work backwards. 1 would be 2, and thus 0 would be 1. So it'd be 1 times 2 to the x. Or, because I know my second term, I could have put my n sub 2, 2 times 2 to the x. Now, since it's my second term, I say x minus 2. Or, I'm sorry, this should have been 4, because this is my second term. Second term is 4. Okay? That's one way to do it. And then recursively, recursive is easy. Recursive is just f of x equals f of x minus 1 times 2. Okay, let's do it again here. So check this out. This is cool. So I see that I'm subtracting 4, subtracting 4, subtracting 4, so I know that it's linear. F of x equals, so now I'm going to use, I have my sixth term. So I'm going to say 23 minus 4, and then x, since it's my sixth term, minus 6. So we can actually say that we can expand this, whoops, let me slide that down. We can expand this part of the equation to be f of x equals n sub t, where that's the term number. Here it's the 0th term, but that could be any term number, n sub t, plus the common difference of x minus t, so that we can use any term number to be able to get our equation, any term number whatsoever. So here, let's go to 15. So 15, I'm adding 6, So I can use that new form that we just created, this new form that we just created to figure this out. My explicit is f of x equals my n sub 6, 7, plus my x minus 6, since it's my sixth term. Pretty crazy. Pretty crazy. Or let's look at this one here. This is cool too. Let's look at number 18. So I see that I'm timesing by 2, but I'm timesing by 2 for every 3, right? I'm timesing by 2 for every 3 steps. So really, what I'm doing is I'm timesing by 2/3. Timesing by 2/3 at each step. 2/3, 2/3, 2/3. Whoa, that's wild. So that would tell me that my ratio is actually 2/3, or not 2/3, that doesn't make sense. It'd be, let's actually figure this out. All right, so if I have 17, 5, and I don't know 18, I don't know 19, but I know 20, and this is 10. Oh, okay. So this means I'm going 1, 2, 3 steps, and I have to get to times 2. So that means this is 5 times the cube root of 2, 5 times the cube root of 2 times the cube root of 2, and then that would finally give me 5 times 3 cube root 2's, which would be 10. Whoa, wild. So actually each step on my common ratio is the cube root of 2. So f of x equals my 17th term, which is 5, times the cube root of 2 to the x minus 17 power. Whoa, that's a wild problem. Good luck with that one. That's definitely the challenge problem. If that made any sense to you, congratulations. All right, gonna call that good. We did a bunch of them. If you have specific questions about these, please feel free and ask me. Otherwise, good luck.